So we've talked about perimeter area, volume, and surface area of different shapes, okay? Now what we're going to do is investigate measurement concepts. So we're going to explore the area of a rectangle with a perimeter of 24 centimeters. So if we think about 24 centimeters, we're going to have a length and we're going to have a width, right? So if you think about it, if we only take the length and we only take the width, one set of length and width is going to equal just 12, because then again, like, we have to double it, right? And then this length and this width is also going to equal 12. So the orangish red here is going to equal 12, and then the green is going to equal 12 as well. So what we're going to do is we're going to make different rectangles, and we're going to make sure that the perimeter is 24, and then we're going to see what happens with the area, okay? So I made a chart here. It's just rectangle 1, 2, 3, 4, 5, 7, all the way to 13. Okay, there's 13 different rectangles that we're able to make with a perimeter of 24. Okay, so for example, first we can have the length of 0 and the width of 12, because then that perimeter equals 24. So length of 0, width of 12. And we know the area equals length times width. So 0 times 12, the area is going to equal 0 for that one. Of course, you can't actually have a rectangle unless you have a length and a width. 0 is not a length. Okay, 0 is not going to make a rectangle. Okay, and then we're going to have, let's do 1. 1 and 1. So if these two here have to add up to 12, it's going to be 1 by 11. Okay, and 11, 11, 1, 1, those all add up to 24. So 1 by 11, and the area is going to be 11. Okay, we'll keep going. 2. 2 plus what equals 12? Well, 2 plus 10. Okay, so 2 and 10 is going to equal an area of 20. Okay, so the length, we can fill in the entire length boxes. 3, 4, 5, 6, 7, 8, 9, 10, and we'll keep going. Okay, and the width, if you can notice this little pattern, 12, 11, 10, we'll do 1 or 2 more. So 3 plus what equals 12? 9. Okay, so 3 times 9 is 27. Okay, and if we do 4 plus what equals 12? Because again, that's half right here. 4 plus 8 equals 12. Okay, take a look at this. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and we'll continue. So let's actually calculate the areas of these. Okay, and if you need to, you can draw every single rectangle. That's totally fine. Okay, so 32, 7 times 5 is 35, 6 times 6 is 36, 5 times 7 is 35, 8 times 4 is 32, 9 times 3 is 27, 10 times 2 is 20. Let's just scroll down. 10, 11, 12 with the pattern. 2, 1, 0, 1, and 11. Okay, so of course, this 0 and 12 is going to be the same as this 12 and 0. This 11 and 1 is going to be the same as 1 and 11. Okay, like the same area, right? It's going to actually be the same rectangle, because if you just turn the rectangle on its side, for example, okay, if this is 11 and this is 1, these here and here are actually the same rectangle, of course, right? So here's the biggest question, and this is part of something called optimization. Okay, you want to maximize or you want to optimize something, and this is very applicable to the real world. So what measurements maximize the rectangle's area? So let's go down this area column right here, 0, 11, 20, 27. Keep looking, and if you take a look here, 36 is the biggest area. Okay, so this is what we're looking for, the biggest area. So we maximize area, 36. Now, the length of this one is 6. and the width of this rectangle is 6. Well, think about that. 6 by 6. What kind of special rectangle is it? This is going to be a square. Okay, so in order to maximize the area given a perimeter, we need to draw a square.